Yeah, we're all shuffling.
I forgot one thing about broadcasting. I told you about two broadcasting methods, or two main methods. There's a third method that I use in my networks. Since you have a random walker walking around, and the good thing about the random walker, it is constantly visiting different parts of the network. Because if you broadcast and collect data on the normal file links you have, that's just data from the neighborhood. You can also broadcast and collect data over the random walker. So every time the random walker visits a node, those two nodes can exchange data. So in that way you can broadcast over only the random walker. So he exchanges data, and the other node also has a random walker, of course. So if you tell him something, he can then tell other nodes that when he visits them. It's a kind of slow broadcast. But if you process, it's actually quicker than thinking like 10 rounds jumps, you actually usually reach the entire network, even if it's like a million nodes. It's quicker than you think. So in a couple of minutes, 10 minutes, 20 minutes, you have reached broadcast over the whole network, if you need to do that. And the nice part about collecting data, it's actually not about broadcasting, it's more about collecting data, of course. The one collecting data about, for instance, nodes that has some service, means that if you do a search, for instance a broadcast search, from that point where you bounced last time, and you don't find what you're searching for, and a while later, if you broadcast from another part of the network, you will search another part of the network. And every time you search or consume some service, you will do it somewhere else in the network. So when you update your tables for nodes that has a service or something, if you do it over the random walker instead, those tables will constantly be renewed and changed. And that means if you get stuck in a bad situation for a while, that will quickly go away. And that may be very useful in some cases. So I use it a lot, and I should perhaps explain that before. I should do most of my slow broadcasting over the random walker, not over the links. I don't use the file links much, really. So that's yet another broadcast method. And then on top of that, of course we use the normal throttling, have all these slots and everything. It's the same kind of broadcasting, just as we do it when we bounce to on another.
And what sort of methods do you use to decide what data to exchange or what data needs exchanging?
Usually because I'm running, most of my algorithms are round-based. So I actually change the same kind of data every time. For instance, I do it with the statistics method. You know, the trend was when I was collecting maximum average values, something like that.
Oh, yeah.
That I exchange over the random walker, because that means the value I get isn't from my neighborhood, it's from the whole network. Because if I collect it just from my neighborhood, of course it's six levels. I could collect it further and further away, but as a rule, some nodes the node in the middle would be represented too many times in here. So it's better to do it over the random walker.
So what about in the situation where you've got, like a message like something wants to announce that it's got something or that it wants something, and that's put out as a broadcast?
Yes.
You don't want those messages being constantly copied between nodes that have them.
That I supply a service, yes, I can. Well, it depends on the situation. I actually use the random walker for my distributed hash table. To learn what nodes, if we have like 16 slots for that, to learn what nodes to fill in each slot that has each subtree, I actually use the random walker to learn about those. So that means my tables now are constantly updating. That means there are several reasons for that. One is to keep the data fresh. The other one is to not get stuck in one part of the tree. That also always learn about new nodes below me, because then if I get stuck in a bad place, I will soon be in a good place. So if I'm stuck I will never be a long time using bad nodes below me. Because by accident I might have a bunch of bad nodes below me. So I constantly move around. Every node is constantly moving around. It's constantly evolving. We'll look a little more about that on that in a few minutes. Actually, it's on the to-do list here. Yeah, but so it's in that case, I actually use it mostly broadcast over that. Because most of these round-based algorithms, they don't need to collect data quickly, just need to get the proper data over time. But as I said, well, on a broadcast search, then simply, if I'm a random walker, I connect to one place, and actually I can leave the random walker. I can still continue walking, but leave that connection for a while, and use it until I have a new place to talk to. And I can do my broadcast search from that spot. And then 1 minute later, when I'm jumping here, I can do my broadcast search from that point. So you can move where I'm doing every time I do a new broadcast search, I will do it from a new place in the network. And of course, well, I can use the random walker. Well, the random walker is the way I find a new place to do it from. Did that answer your question?
I guess so.
Yeah. So my broadcast search, actually, I should perhaps write. There's one view cloud. Everyone is part of that. And then we have all those mini groups in here. So your broadcast search will go out in different directions like that. And those nodes are connected to different mini groups. But that still means if I search from the same point, a minute later, it still reaches the same node. So if I instead search from here, I will reach another group of nodes that are connected to other mini groups. That's clear? Yeah. So, yeah. No. Oh dear. The routing, we're getting back to that one now. Because it seems people are having trouble with that, but several people are asking kind of the same questions. Let's see. I don't know really how to make pictures of it. So let's use the bucket model, since people seem to be familiar with that. While I'm walking around, well, there's two ways to do it. If I have my connections, if I'm, for instance, a node of type 15, let's see if I can make a picture of that. Zero, 14, 15. That's not 15. Every node in the big cloud, of course, needs to know of the nodes in bucket 15, in the subgroup 15, in S1. So I need to have a list of node addresses here, at least 3. And I need it for every bucket here, for all these ones. And there are several ways I can learn about those. For instance, if I'm a node of type 15, that I'm actually in here, I can ask to my neighbors that I'm a node of type 15, or that I'm working in, my address starts with 15, and a jump counter on that, of course, also, because everything in broadcast will jump. You put a jump counter on. And my neighbors will broadcast that further on. And with the change, the view in this part, all of my friends will give me one node address that's for a node that is of type 15. So I will get 5 of them. So I will learn about 5 of them. And if, for instance, some node, the path here disappears because some intermediate node disappears, or actually the node 15 disappears, some other node will have the shortest path here, and this node will suddenly tell me that now I have a new one, number 15, that I consider the youngest. They will constantly keep me updated like that. But that will be static. That will, most of the time when the network is stable, I will see the same 5 nodes of type 15 all the time. So that might be, as I said, destructive if all those 5 is not working very well. So instead I can use the random walker. When I bump into another node, it gives me a list of 16 different nodes, 1 for each of the buckets, and tells I know about these 16 nodes, 1 of each. And I put it as, well, I put it at the top of the stack here, and I throw away the oldest one. So that means every time I walk around, I can fill in each bucket with 1 new address, and I can remove 1. And also, it's the same thing, it has a jump counter, because when I bump into someone else, I'm supposed to give him 16 addresses. And most of them will, of course, be the one that people have told me recently, the youngest ones I have. And one of them will, of course, be myself, because that's the youngest one. If I'm, for instance, node 15, the one I give to others will be me. And we also need a jump counter on. Jump counters on when you bounce around like that's a bit special. Say we jump around once per minute. That's a bit slow, but let's say that. Then when I transfer that data to the other node, the jump counter in that package will increase by 1. And then it will get stored in that node and will start telling other nodes about that, if it's the youngest message. But also, once per minute, it will increase the jump counter in that package. So it gets older also when it's stored. So, but you can have the same jump counter. It doesn't matter, just raise it by 1 in both ends. In that way, if I learn about a new node that is younger, I will throw away the old message and start broadcasting that new message. So in that way, we can have these buckets filled with fairly fresh nodes that were seen recently seen nodes that were online recently, some minutes ago. So they won't be very old. Because of course, the recently seen nodes are likely to be online still. What do you say about this?
And because even if there are nodes that are old, because they're announcing themselves.
Sorry, that?
With nodes that are have been around for a long time,
yeah.
They're still announcing themselves at the top of their list.
Yeah.
So
they will become continuously visible. And actually, they decide themselves how visible they are, because every time they bounce into someone, they are announcing themselves. So that means everyone that is actually bouncing around are announcing themselves at the exact same rate. 1 bounce per minute, 1 announcement per minute, and that's then broadcasts on. Yeah, that was one. But I don't make any difference between nodes who are been online a long time or a short time. I consider every node useful, because my algorithm actually makes the network consistent so quickly. So as soon as a node is online, it clones some other node that has every data working, and then it can start acting, take incoming calls and outgoing calls and everything. So I want to get them fully working as fast as possible, because some networks might be networks where most nodes will be just for a short while. So I don't differentiate between nodes who've been online for a long time and a short time. Instead, I keep all my data so fresh that it doesn't really matter that if they're old or young. But I know many other networks that try to instead fill their buckets with, like Academia, and they fill their bucket with nodes that have been online for a long time, because they consider that they are more likely to be there when you need them. But they get some nasty effects by that, and actually we're going to talk about that effect now. Or any more questions about that so far? So is everyone grasping this routing method? Yeah. Because that's well, not everyone uses, but many DHT users now.
Is there because you end up collecting as it gets further down, it collects nodes that have like a prefix. So like in the next bucket, there's ones that, like there's 15, 15.
Yeah.
So just as you receive nodes, it filters. So like.
Well, I have a random walker in here, I have a random walker here, and I have a random walker in here.
Right. In each level. But each node is in every level.
Yes.
Yeah.
So if my node, for instance, is, let's see, it's a hex address really. If my node is 15, that's F, right? F 0 5 A G B. Oh, you're up to G. I suck at hex. Thank you. Let's take an 8. So that's my node address in the DHT. So on the first level, I would be in number 15, because that's F. Then in number 0, number 5, number A, 8B. And I would have be part of this, connected in this form, and have my random walker and in that one, and that one. So
you eventually direct yourself to the node that knows about the 05 A prefixes.
Yeah. But this is the node itself is taking part down here if it has this address itself. So it's actually working in that little group. So taking part of the group with this address.
Yep.
And anyone that want to find it can of course go in here. Well, it's already in there of course, because everyone is there. It just goes to, checks in the 15 bracket and takes those 3 and connects to them and see, can you tell me about F0? And they can tell you about the next number you ask them and just jump down there. So that's the routing over
So
there.
how many connections does it need to make to find a node? Like if you have millions of nodes?
Well, if you use UDP for it, that means, let's say it's a million nodes,
Mhm.
that's 20 bits, and it's
5
4 bits, 5 levels, yeah. 5 levels, is it 1, 2, 3, 4, 5, or is it 0, 1, 2, 3, 4, 5, I'm not sure now. Anyway, that means you have to do, in here you don't know it, you already have the data, so you send 3 packets here, asking 3 nodes, and get an answer for at least one of them, hopefully. Otherwise you have to ask again.
Yep.
And 3 there times, well, 5 is, that's 3 times 5, 15 UDP packets outgoing, and about 15 coming back, of course, because most.
And how much do you need? How much data do you need to keep in memory?
You just need to remember the next 3 that you're going to talk with.
Oh no, but for this whole structure to work.
Ah, you mean the node that is
I
working
asked
down
about
here?
it.
How much does it need to know?
Yeah.
Okay, on each level it has 16 buckets.
Yep.
And in each bucket it has to have at least the 3 latest ones.
Yep.
Because it might get questions about those 3, be able to tell them. So that's 3 times 16. Sorry.
That's
32, 48. No, sorry. 48.
Yeah.
So 48 node addresses here, and in 48 in each level. So say it's 5 levels, 48 times 5, well, 50 times 5, that's about 125 node addresses. If it's 5 levels. And that's for 1 million nodes. And that's all you need to keep track of.
What if you had, say, 256 buckets per level?
Yeah, yeah.